Enter stage left, Baby Shakespeare. It outputs text that mimics the exact structure of an Elizabethan play, complete with character names and distinct rhythmic dialogue formatting. But read the actual words, and it is absolute nonsense. Modern language models consume massive server farms and boast billions of parameters. Baby Shakespeare has just 117,888. It was built using pure Python, run on a single CPU, and trained in exactly 8 minutes and 1 second. We rarely see models in this state because of the provenance problem. The tech industry's standard practice is to only present an AI once it produces impressive results. The awkward beginnings, early mistakes, and exact training data sets are routinely scrubbed or buried. But Baby Shakespeare's babbling is intentional. Its attention weights were deliberately frozen at random initialization to guarantee it would never produce coherent thoughts. The model is a highly restricted character frequency calculator trapped inside a transformer-style architecture. It was built specifically to test a new cryptographic standard using this raw historical data. The purpose of this experiment was never to write literature. It was to prove that an AI's history can and must be immutably recorded, starting right from its most embarrassing origins. This shows the exact consequence of freezing the attention weights. It learned the visual shape and rhythm of Elizabethan English, stripping away underlying logic and semantic meaning. This output is not a failure. It is preserved as a highly specific, documented developmental state. It exists to demonstrate VATS, the Verifiable AI Training Specification. Under this framework, the actual product is not the AI model itself, but the cryptographic record of how it was constructed. The process begins chronologically. A training intent manifest detailing the exact dataset and parameters is drafted and finalized before the 8-minute training run even begins. By logging the intent prior to execution, developers lose the ability to review the final results and then quietly rewrite their original narrative. This timeline tracks the fingerprinting process. Every artifact in the cycle, from raw source bytes to initialized weights, is sealed with a unique SHA-256 hash. Those hashes are published to Arweave to guarantee permanent storage of the record. Simultaneously, the record is anchored to the Bitcoin blockchain using an op return transaction, securing an unforgeable timestamp. This creates a mathematical guarantee. If a single byte of data is retroactively altered to hide a mistake, the hash instantly breaks. The specification also enforces a gap declaration. Creators must explicitly document their blind spots, identifying exactly what their model does not know and which artifacts are missing. In July 2026, an external AI model hallucinated a missing gap document, confidently inventing the text to fill the void. The VATS verification step caught the lie immediately because the original cryptographic hash was absent from the ledger. By making cover-ups mathematically detectable, the protocol forces the industry to abandon its reliance on opacity. For years, developers managed their models using internal, editable web pages. Now, the industry is transitioning toward evidence readiness, prioritizing records that are locked in long before anyone asks to see them. This shift is playing out in massive copyright litigations, where developers are currently struggling to legally prove exactly which images or articles were included in their training data. Sweeping regulations like the EU AI Act will legally demand immutable proof of training origins. This creates a strict regulatory trap. Evidence cannot be created retroactively. Any documentation not anchored during the initial development window becomes an illegal gap that companies will have to explain to auditors later. Which brings us back to Baby Shakespeare. Future versions of this AI might grow more capable, but this exact, babbling 8-minute developmental milestone is permanently locked into the blockchain. The future of responsible artificial intelligence will not be judged strictly by what a model can ultimately do. It will be judged by whether its creators can cryptographically prove exactly where it came from.